Welcome to the second video of Module 1. We will discuss the units of measurement in this video. The learning outcomes for this part are: identify and report measurements using the SI units, identify the units' prefixes and how to use them, convert to different units using the unit conversion factor method, and solve questions related to different measurements. Remember that measurements usually consist of two parts, the number and the unit. We discussed the number earlier, and now we are going to discuss the unit. The unit part is equally important to the number. So in any measurement, if you only report a unit, then it won't make sense to the reader. Equally, if you only report a number without the unit, it will also not make much sense. We have many units that can measure the same thing. For example, inches, miles, meters, centimeters, kilometers, and nanometers are units that can be used to measure a length. To avoid the confusion, scientists agreed to a set of units that is called SI units, from the French phrase Système International, or what we call the metric system. In this system, scientists agreed to use only one unit for each type of measurement. For example, length is measured by meters, mass by kilograms, temperature by Kelvin, and seconds to measure time. Using the SI system makes communication easier between scientists, as it is recognized globally. For some measurements, the number might be too big or too small, so we have prefixes to help with that. For example, the kilo prefix means 1000, so when we say 1 kilogram, we mean 1000 grams. Milli means 0.001 of the unit, so when we say 1 milligram, we mean 0.001 grams. We will use most of those prefixes when doing the weekly exercises and the workbook, so you need to learn and memorize them. Pico and femto prefixes are not that important for our course. Now, how do we convert from one unit to another? This concept confuses many students, so it is recommended to practice unit conversion a lot to master it before the first assessment. The weekly exercises and the workbook provide several practice questions. There are different ways to convert units, and you can choose any of them as long as you get the correct conversion. The textbook uses the following method. Unit 1, what you have, times the conversion factor equals Unit 2, which is what you want. Please be aware that you don't need to remember the conversion factors from the American units to SI units. This information will be given to you if needed in the exam. However, you are expected to know how to convert from hours to seconds, from grams to kilograms, and so on. Let's look at the following example. The distance from the Gold Coast to North Brisbane is approximately 55 miles. We are told to express the distance in kilometers. To do the conversion, we need to know the link between miles and kilometers. From the textbook, you can find that 1 mile equals 1.609 kilometers. Please note that you don't need to remember this conversion factor. Now we know the relationship between miles and kilometers. We can do the conversion. The relationship between miles and kilometers can be written as a fraction, and this is the easiest way to use the factor to do the conversion. This means there is 1.609 kilometers for every 1 mile. Now we apply the method we learnt earlier. 55 miles times 1.609 kilometers over 1 mile is equal to 88 kilometers. Now we need to consider significant figures in this example. 55 miles is the only measurement in this example and has two significant figures. Remember that conversion factors are exact numbers, so we don't need to count their significant figures. So our answer should contain two significant figures. Let's practice another example. A car is travelling 55 miles per hour. Convert the speed to kilometers per second. We have two units for this measurement. Miles need to be converted to kilometers, and hours need to change to seconds. Remember that 1 mile is equal to 1.609 kilometers. It would be considered general knowledge to know the conversion from hours to seconds. So first let's convert from mile to kilometer. We'll use the same method as earlier. 55 miles per hour times 1.609 kilometers per 1 mile equals 88 kilometers per hour. Now we can convert from hours to seconds. 88 kilometers per hour times 1 hour over 60 minutes times 1 minute over 60 seconds equals 0.024 kilometers per second. You can do this conversion in one step. 88 kilometers per hour times 1 hour over 360 seconds, 3,600 seconds equals 0.024 kilometers per second. Again, we need to consider the significant figures. Conversion factors are not counted, so we only have the measurement 55 miles per hour with two significant figures, and our answer 0.024 has two significant figures, so that's all good. What if we want to go backwards in the previous conversion example? So we want to convert the measurement from kilometers per second to miles per hour. How can we do that? Let's use the same example where the car is travelling 0.024 kilometers per second. Convert that to miles per hour. We use the same method. 0.024 kilometers per second times 1 mile over 1.609 kilometers equals 0.014916 miles per second. Then we take this number multiplied by 3,600 seconds over 1 hour equals 55 miles per hour. Now let's cover some of the most commonly used measurements in the lab. Mass is measured by kilograms. It is important to note that mass and weight are two different concepts. Mass is the amount of matter in the object and is measured by kilograms, whereas weight is a type of force that is measured by the unit Newton. This force takes gravity into account. The SI unit for mass is kilogram, and you need to convert back to this unit when reporting your measurement. As we said earlier, you don't need to remember the conversion factors from the American units to SI units, and this information will be given to you if needed in the exam. Some examples of other units that are used to measure mass include stone, pound, ounce, etc. In this table you can find some prefixes that are commonly used to measure mass. Centigram and decigram are rarely used. The most common ones are kilogram, gram, milligram, and microgram, so please remember these ones. The second measurement is volume. It is similar to the length but multiplied 3 times. So volume is three-dimensional and the SI unit is meter cubed. In the lab we usually use litre, milliliter or microliter for a very small volume. Temperature can be expressed by different units such as Celsius, Kelvin and Fahrenheit. The SI unit for temperature is Kelvin. To convert from degrees Celsius to Kelvin, you need to add 273.5. So 0 degrees Celsius equals 273.5 Kelvin. Similarly, 0 Kelvin is equal to minus 273.5 degrees Celsius. In the US, they use Fahrenheit, which is another unit to measure temperature. The conversion factor in this case will be given to you if needed in the exam. Density is also used a lot in the lab. Density is not a unit, but a ratio of the mass to the volume. So using the SI unit, we know that mass is measured by kilograms and volume by meters cubed. In the lab, we usually use grams for the mass and milliliters for the volume. Density is a physical property of substances. For example, water at 4 degrees Celsius has a density of 1.000 grams per mil, or 1.000 kilograms per litre. Please note that the density is related to temperature, so when the temperature changes, the density changes too. The reason is that in different temperature, the volume either increases or decreases. The mass remains the same at all temperatures. This change in the volume causes the change in density. Let's take a look at some examples of the density. From the table, you can see that the water density is 1. Gold, on the other hand, has a density of 19.3. So if we have the same volume of water and gold, then the gold is 19 times heavier than water. Wood, on the other hand, has a density of 0.512, and that is the reason it floats on water, as it is lighter. Just remember that all these density values depend on the temperature. And the other thing to note is the unit. As you can see, the density is measured by grams per milliliter. However, if you check the unit for the gas's density, you will see is measured by grams per litre. This is because the gas density is usually smaller, and thus we measure the volume in litre to make reporting the density easier. Remember that you can always change units using the conversion factors that we have discussed earlier. The lecture for the first module is now finished. We are going to summarize the key points in Module 1. First, we talked about the steps of the scientific method. One of these steps is the experiment where you get results. Generally, results consist of two parts, the number and the unit. Then we discussed the number part. Firstly, we talked about how to present very big or small numbers using scientific notation. Then we discussed the quality of the measurement and how to reflect that using significant figures. So the more significant figures in the measurement, the higher the quality of your measurement. In the significant figures, we talked about the rules for counting. We covered the 0 digit and in which cases it is considered significant and which it is not significant. We also talked about the rules for rounding off numbers to obtain the accurate number of significant figures in a measurement. After that, we covered the rules for calculation, and we discussed that when doing addition and subtraction, we look for the least number of decimal places, while in multiplication and division, we consider the least number of significant figures. After that, we talked about the SI units and gave some examples. We also looked at the conversion factors and learned the method to convert from one unit to another. We also covered some important measurements like the mass, volume, and density. Finally, remember that measurements are approximates and the quality of your measurement depends on the quality of your tools. This is the end of Module 1. Please practice the weekly exercises in your textbook and the questions you find in your workbook. We will meet face to face in the tutorial session, and this will be your opportunity to ask any questions or clarification.